Good afternoon, everyone. Hope your lunch was good. Hopefully I can make sure to keep the content here engaging enough so that you're actively entertained and not falling asleep after the nice lunch that you've all had today. So I hope you're all having a fantastic day so far. Today, we'll be discussing detection as code, how my organization has implemented it, some lessons learned along the way, and how I think it could benefit your organization as well. It's quite likely that many of you in the audience today have encountered a rendition of this quote or something of similar sentiment before. In my search for a widely recognized individual to give credit to this quote, I actually came up empty-handed. I believe this is because variations of this idea serve as a prevailing mantra within security and observability teams. Now, consider how the concept of detection as code perfectly aligns with this principle. By structuring detection rules as code, we enhance our ability to identify and respond to threats, ultimately strengthening our overall security posture and reducing the opportunity for errors that can occur in a more traditional approach to managing detection rules. So who am I? I wrestled with actually what I wanted to share here. I wanted to avoid the more typical resume-style introduction, focusing solely on my background and skills. Instead, I'm going to take a moment to speak towards my professional values and mission. I'm Kelly Bettendorf, a staff security engineer at Stavvy. My personal goal is simple, yet significant in my opinion. I aim to deliver at least one meaningful change to every organization that I have the opportunity to support. Now, you might assume that by significant change, I mean something groundbreaking. And while sometimes that's the case, I find it's often the small, organically impactful actions that leave the most significant mark. I strive to make a lasting impression on my colleagues and communities. You'll often catch me opening meetings with a simple Happy Monday, or whatever day of the week it may be. And you'll also find me contributing to the Datadog Slack community channel, answering questions as time permits. Maybe I've even spoken with some of you there today. With that, thank you for selecting this talk. I'm thrilled to be here and share the journey that Stavvy has undergone as we've explored and implemented detection as code. Taking a moment to share the spotlight on my company. Without them, I wouldn't be standing here today. At Stavvy, our digital transaction platform is a game changer for financial institutions. It enables them to transition from a traditional paper-paced and in-person process to a modern digital experience we've all come to rely on in our day-to-day lives. I want to extend my thanks and gratitude to the executive leadership at Stavvy for their unwavering support. They've empowered our security team with the resources needed to explore impactful solutions that challenge our everyday state. Interesting. While evaluating detection as code, it was really important for me to approach it with a high level of skepticism. In the fast-paced world of technology, I believe we've all encountered new innovations that initially seem promising, but ultimately add unnecessary complication and time compared to the time and resources that are invested. It was essential for me to thoroughly assess whether detection as code addressed our needs and provided tangible benefits without introducing pointless complications in our existing solutions. We can break down today's content into 5 main groups: assumptions, common challenges I've seen with traditional approach to managing detection rules, an introduction to detection as code, a review of supporting technologies that make detection as code possible, and then we'll move into some practical application examples. As we move forward, there are some assumptions that I've made about what an organization's maturity looks like when considering detection as code. You're utilizing both Datadog's SIM and logging solution, as this is required for detection rules. You've spent time understanding and tuning your out-of-box rules, and you've likely added an additional handful of custom rules yourself to improve on your alerting that you have in place today. You have an understanding of your log sources, meaning that most of the time when you need to run a query, you know exactly what indexes or source types that you're going to use to find exactly what you're looking for. You're regularly reviewing and refining your log sources to ensure they provide relevant and actionable data, and your data is parsed in a usable way. In addition to spending time to proactively extract facets from all of your log sources, enabling data transformation actions to better improve and empower your end users. You're already using, or you're open to including the Datadog audit log feature, And I'll go into more of this later, but in my opinion, utilizing the audit log feature is a critical component to using a mature detection as code solution. And your leadership is open to evaluating and considering changes in your organizational strategy that could have a large shift in your day-to-day operations. And while a bit opinionated, if your organization doesn't align with most of these points, looking at detection as code might not be the right time to look at detection as code. While challenging my understanding of what detection as code means, I've come to appreciate its varied interpretations. For me, detection as code represents a shift towards a DevSecOps approach. Leveraging the principles of infrastructure as code to enhance the creation, management, and deployment of detection logic. It's about integrating security seamlessly into the deployment pipeline to reduce operational inefficiencies and enhance security posture and confidence. Anyone who spent time working with, creating, maintaining detection rules will be all too familiar with some of these pain points. Multiple users adjusting your detection logic for the same rule, with different ideas in mind, resulting in a flood of alerts, or perhaps accidental double negatives that cause your alert to stop functioning altogether. I can personally recall more than a few instances where the traditional approach to detection rule management has resulted in quite a bit of internal frustration at various organizations that I've had the opportunity to support. One time I had to explain to senior leadership that a well-crafted rule created from a prior incident and designed to inform support teams in the event that the issue occurs again was somehow disabled, resulting in a lengthy investigation process, only for us to find out that what we thought was monitored was unfortunately not. Or another time that an analyst intended to update our global reference table that we used as part of our monitoring logic, and they replaced the large list of vetted entries with a handful of new ones, resulting in deleting all of the existing entries. And unfortunately, we had no undo or backup of that resource, and we had the opportunity to start over from scratch. I've seen instances where organizations struggle to balance permissions around who can create or update detection rules. Add too many people and you introduce more risk. If you don't have enough people, you can't keep up with all your tuning requests. Challenges around personal preferences when it comes to detection logic design, where one individual may choose that they want to use nested values for all of their groups, and another may want to declare each attribute or variable independently. One of the more frustrating outcomes is when you have a handful of alerts that come your way, but they have no information supporting why that alert even exists, and it's now become you or your team's job to figure out what the intention of that alert was. And while not a perfect solution, implementing detection as code can help improve many of these pain points. Imagine for a moment where many of the pain points of traditional detection rule management are greatly improved or eliminated, where inconsistency and frustration transform into every team member being empowered to contribute to your organization's security posture without fear of negative repercussion, where detection as code serves as the foundation for the entire rule management process using templates that account for everything you expect and require of your detection rules. Templates made available to anyone in your security team or even your whole company, where users can populate the templates and then send them over to your approvers. Your approval team then reviews the proposed modification and changes and either accepts it or rejects it with feedback. And both of these outcomes are great. In the first one, it means that the contributor has followed all the requirements and have passed a peer review. And in the second outcome, it turns into a teaching and learning opportunity for improvement. Finally, after it's been approved, the rule has been deployed to Datadog and it reflects your expected code state. And just in case if someone does have elevated permissions and they make unplanned changes or unapproved changes to your detection rules, well, that's going to get automatically removed, and your security team is going to be informed of the unintended change. We're going to cover this a little more later on. Up to this point, we've talked about common pain points, how detection as code can offer a solution, and we'll spend a few minutes talking about the supporting technologies that make detection as code possible with Datadog. Version control systems are the backbone of modern development, offering a range of benefits for teams and projects. Version control systems meticulously track changes made to files, providing comprehensive history of edits, additions, and deletions. By leveraging these capabilities, teams can collaborate more effectively, maintain code quality, and deliver better detection rules. Your version control system is more than the tool for tracking your changes. It becomes the foundation for your detection strategy. It ensures that all rules are accurate and reliable and up to date. What makes your version control solution your source of truth is all about how you're using your code repository. You must be able to confidently say that any detection rules outside of your repository are not considered high fidelity or long-term. In other words, if you woke up tomorrow and found that any detection rule outside of your repository was gone, you wouldn't worry about it because everything that's important to you is kept in your repository. Terraform empowers you to command your digital resources, such as servers, databases, and networks across the vast multi-cloud landscape. Instead of tediously typing out commands or navigating through numerous menus over and over again, Terraform gives you a solution to establish your requirements just once and reuse them as needed, ensuring consistent and predictable deployments. Another way of looking at it is Terraform makes it possible to create golden images for nearly endless amounts of resources. Terraform providers act as your bridge between Terraform and various cloud platforms, services, and products, enabling the use of infrastructure as code. While our focus today is on using Terraform with Datadog for detection as code, it's important to note that Terraform providers extend beyond just one platform or product. They will allow you to interact with a wide range of services and providers. Think beyond Datadog. Detection as code approach can be used with many security products, including firewalls, VPNs, EDRs, you name it. You can find a full list of all of the supported providers at registry.terraform.io. When simplified, a continuous integration and continuous delivery solution automates the deployment of your code in a secure manner. While typically utilized by DevOps and engineers, security teams can also leverage it and take advantage of its benefits. By bringing Terraform, version control solution, and CI/CD together with Datadog, we have everything that we need to build out a mature detection as code solution. We have reviewed common challenges with in-tool managed detection rules, as well as supporting technologies that make detection as code possible with Datadog. Now we're going to move on to looking on some practical examples that build on everything we've talked about so far. Thinking about how I wanted to break down this approach, I decided on a crawl, walk, run model, where each phase builds on the former. At the crawl phase, we're using Terraform locally. At the walk phase, we have moved from a locally managed to a shared code repository and set up Terraform to use a common state file. Lastly, for our run phase, we're using CI/CD for managed deployments that include drift protection and self-healing. Breaking down the crawl stage, starting off by setting up a service account in Datadog that we'll use with our Terraform deployments, installing Terraform on our local system, setting up the local Terraform files, and running a locally ran Terraform to deploy our detection as code rules. A quick disclaimer, any of the content that follows I've actually staged in a sandbox. Any of the keys or secrets you see that are included are not valid, and it's always recommended to follow industry best practices, including least privilege, and to avoid hard-coded secrets. Okay, now let's take a quick look at the steps required for us to set up our service account in Datadog. First, we're going to go ahead and create a service account. We're going to go ahead and give it the name Terraform. And while you'll see that I'm using the administrator role here with this service account, you'll want to scope its access based on your organizational needs and intentions on how you plan to use it. After creating our service account, we can go ahead and click on it here and expand it. And then we're going to go ahead and add an application key to associate with our service account. After we generate our new key, we're going to copy the value for later use. Next, we're going to go ahead and create an API key to use with our new service account. We're going to give it the very creative name of Terraform. And we're also going to go ahead and copy this value for later use as well. With our Terraform service account in place, scoped to the desired permissions, and both our application key and API key ready, we're ready to move on to installing and using Terraform locally. For Linux and Mac users, installing Terraform using brew is incredibly simple. Run the command brew install HashiCorp tap Terraform and let brew do its thing. It's also worth pointing out that Terraform has undergone a license change. For organizations who prefer fully open source solutions, OpenTofu is a compatible open source fork of Terraform. For our Windows users, installing Terraform is not quite as simple, but still not difficult. You can go to the HashiCorp Terraform installer site, download the Windows installer, and extract it and set up an environment variable. All right, next we're going to take a look at our Terraform files and structure. OK, so here we are in VS Code looking at our working directory. We're going to start by breaking down each of our resources and naming conventions. For our naming conventions, we're going to start with the value of custom_type, followed by an added description to help understand which Terraform file we're working with. And we're also going to utilize the OOB_rule to indicate any Datadog out-of-box rules we're managing with Terraform. Our suppression_rule is going to be for tracking any suppression rules we are managing. And lastly, we'll have our main.tf file, which is used to store our provider details, enabling Terraform to manage resources within Datadog. Taking a closer look at our main.tf file, we can break this down into two major parts here. The top section is our required provider, and in this case, we're including Datadog provider. And for the second part, we have our Datadog provider options, including our API key, application key, and an optional API URL that's utilized to specify which region our Datadog account is hosted in. Out-of-box rules are a set of rules provided by Datadog, which we can enable and use based on our existing log sources. While out-of-box rules provide a great starting place, they are intended to serve a wide audience, and many organizations will quickly find that some out-of-box rules aren't quite what they need. Due to how out-of-box rules are maintained and delivered by Datadog, we are limited in what we can do with them. Our options are limited to applying a suppression rule to reduce false positives, or to disable the rule and replace it with a custom one. By replacing an out-of-box rule with a custom rule, we can account for organizational unique characteristics and needs. Here we are looking at an example of our Terraform out-of-box managed rule. Our options to the resource, again, are pretty limited. We can either enable or disable the out-of-box rule by updating the true or false condition seen on line 10. For any out-of-box rules that you plan to disable and replace with custom rules, it's a good idea to manage them with your detection as code approach. In this example, you can see that I've added a changelog entry to justify why we are also disabling this rule. It's also worth pointing out, before you can use a Terraform or use an out-of-box rule with Terraform, you do need to import the rule to your local Terraform state file before you can manage it. You can see on line 4 that I've included an example of an import operation command. We've looked at setting up Terraform locally and managing our out-of-box rules, and now we're going to take a look at some custom detection rule templates. Now, taking a closer look at our detection rule template, we can break this down into 3 major components. First, we have our resource and message section, followed by our query and case section, ending in our options and tagging section. Taking a closer look at our first section, the resource value is used by Terraform to know what resource type we're working with. The resource name that follows will be used by Terraform to track resources in the state file. The name value on the next line is the detection rule name as we would see it within the Datadog UI. And for our message section, we're utilizing an EOF text block for readability and to record our alerts, goals, triage, response steps, and changelog. For our next section, we're going to go ahead and deploy this rule in an enabled state. For our query name, we're going to use the default A value, and we're only using one of the 10 supported queries at this time. For the query value, this represents the search as we would use in our log explorer to identify the traffic in question. For our aggregation, we're going to go ahead and count on the number of occurrences grouped by username. For our case logic, we're going to set the criticality level and threshold, and in this case, we only want to generate an alert when events in question for a username occurred 10 or more times during our selected rollup window. In our options section, we're going to go ahead and configure our detection method and evaluation criteria. For our tags, I'm using a minimum of 3 tags for each of our detection rules, where the first tag represents the intended log source that the detection rule is supposed to monitor. For our second tag, we're using a value of source custom. This will help us track all of the rules that we've created and we're managing in-house. And then for our third tag, we're utilizing source of Terraform to have a clear indication of which resources have been manually created in-house within Datadog or that we've deployed and we're managing with Terraform going forward. So we built it, we've looked at our example files, let's go ahead and deploy it. Here in our command prompt, did my video start? There we go. Here in our command prompt, we're gonna go ahead and start off with a Terraform init command, and this will initialize our Terraform backend. We're gonna also utilize the fmt command, as this will format our existing Terraform files and keep them well formatted and easy to read. After running the Terraform apply command, we can see the changes are ready for deployment. We need to provide a value of yes for the deployment to start. You'll see at the bottom here that we have an error related to our out-of-box rule because it failed to deploy the rule because we haven't imported it yet. Using the Terraform import command we talked about earlier, we can go ahead and bring the out-of-box rule into our Terraform state file, and then after running Terraform apply a second time, we're good to go managing the out-of-box rule going forward. Moving from the crawl phase to the walk phase, there's not a lot I can provide a demo on with the time that we actually have available today, but the key changes involve moving away from locally managed and ran detection as code state to a shared state. One aspect of Terraform that I've mentioned but mostly skipped over is the Terraform state file. The state file is how Terraform tracks and deploys resources that it's managing. For our walk phase, it's important to use a state file from a shared location that's accessible to all team members or anyone who's using Terraform to manage your detection rules. Cloud storage providers offer a great solution as a place that you could store your state file. At the walk phase, you're also going to store your Terraform files in a version control solution, making them accessible to your wider audience. It's also advisable that at this stage you're using a secrets manager with Terraform, making it possible for Terraform to grab secrets as needed, ensuring that there's no hard-coded values, locally stored sensitive variables, or exposing secrets in clear text during Terraform deployments. Trying to retroactively remove secrets from your version control solution can be a real pain to deal with. It's best to plan ahead and avoid it. As part of the walk phase, you're also going to move your suppression rules over from app managed to detection as code. It's very important when considering a detection as code solution that you bring all aspects of your detection as code into your Terraform managed resources. Suppression rules are very powerful and can be used to alter the behavior of any custom or out-of-box rules. If you ignore managing your suppression rules as code, you are more likely to run into instances where your detection as code rules are going to be unintentionally affected by your suppression rules, resulting in your rules not working how you expect them to. In this suppression rule example, I want to draw your attention to the rule query value seen on line 17. You can see we're filtering based on rule ID, and if your suppression rules are using any rule query value that is more open-ended, really anything that is not the unique ID that's generated for any of your custom detection rules or any single detection resource, you could find yourself in a position where a new detection rule that you've deployed unintentionally falls within the scope of an existing suppression rule, causing your rule to not function how you expect it to, rendering the detection rule pointless. I strongly recommend that any use of your suppression rules is going to utilize rule IDs in order to avoid this. If you recall towards the start of the presentation, I also mentioned that using the audit log feature, in my opinion, is very important for ensuring you have a mature detection as code solution in place. While the audit logs are valuable on their own for understanding the who, what, and when as it relates to changes and actions within your Datadog environment, we can also leverage that audit log with our audit log monitor to look for detection or changes against our detection resources. By using an audit log-based monitor, we can detect and alert on user actions against our Terraform managed resources and actually create a notification and be notified of any drift from our desired code state. Here's an example of how we're using a detection as code audit log monitor to alert us for changes related to Terraform resources. If you look at the query statement on line 26, you can see we're going to alert on any occurrences where there's a manual deletion or modify event against our detection or suppression rules, where the modification does not originate from our Terraform service account. In our exclusion logic, we are filtering on the API key associated with our Terraform service account and the expected user agent. This logic could also be further improved by trying to include information like the expected source IP and geolocation for whenever your Terraform service account is utilized. When this monitor triggers, it will create a notification that informs the security team when someone has manually made any changes to your Terraform managed resources, and that's something we shouldn't see happening. In my opinion, this kind of alert fits perfectly as part of a 24/7 alerting strategy for high-risk activity that justifies escalation. At the run phase, your detection as code is fully integrated with your CI/CD solution, and you're supporting it with your organization best practices with peer reviews on any pull requests prior to merging and deploying changes with Terraform. Additionally, taking advantage of your CI/CD solution, you're going to set up a scheduled auto deployment for your main branch. I find that running an auto deployment at least once a week is helpful in identifying and addressing any drift between the existing code state and what your resources are, like in Datadog. We can also further build on this by using Datadog's workflows. We can use our existing audit log monitor and alerts to also include a modification to the Terraform managed resource that triggers a workflow that kicks off a deployment from our CI/CD solutions main branch to redeploy our expected detection as code state. This approach means that not only will the security team be modified when someone has made a manual change to Terraform managed resources, but it will initiate an automated deployment, replacing the modifications made to the resources in a matter of minutes. So here's a look at what our end result is. On the left side, we have a well-structured set of managed detection rules that have all been peer-reviewed and refined for high accuracy. On the right side, we can see consistent usage of tags, rule names, and all resources are owned and managed by our Terraform service account, with each of our rules including documented changelog, tracking how the rule has improved over time, a defined purpose, as well as a documented investigation and triage steps. We can include helpful links and tools and resources utilized that are relevant for each of our unique alerts. At Stavvy, we've adopted a bit of a hybrid approach, where I wanted to remove the intimidation and frustration that can be associated by only supporting and requiring detection as code. We're leveraging what we refer to as immature alerts. Alerts that conform to our tagging requirements, excluding the use of the Terraform tag, and we allow our users to test and build the initial versions of their detection rules utilizing the Datadog UI. We time box the lifespan of the immature alerts, typically keeping the notification levels for them as informational, and we don't require that they're triaged by our security team while the rule is being refined. Once an immature alert has reached a level of maturity and high confidence state, the rule must be migrated to a detection as code rule for long-term management. I find that this approach removes resistance in trying something experimental, and it sets a clear understanding that relevant rules must be turned into code. Using tagging and service account strategies that we've looked at today, it's easy to filter on our existing Datadog custom rules, excluding the ones that we've deployed with Terraform, and this leaves us a nice clean list of all of our immature alerts that we know need additional attention and refinement. Regardless of the detection as code maturity state you may start at, it's okay if it's not perfect. Improve your process through iteration and learn what works best for you. I'd like to leave everyone with a bit of a challenge. Take action to determine if moving to a detection as code solution is right for you. To that end, I published all the working Terraform files here on GitHub. You can download them, install Terraform, set up your service account with your provider, and you can get your first detection as code resources deployed in less than an hour. And with the time we have left, I'd love to open the floor to any questions.
Thank you, Kelly. Thank you, big round of applause. Do we have any questions? We have a mic just here, and I will leave this one just there.
Hi. So I was implementing something similar at SeatGeek, and I was wondering, something that I was trying to figure out now is a way to, if someone creates a detection rule within Datadog, a way to automatically generate the Terraform code from the created rule. Have you thought about doing anything like that?
That's a great question. It kind of overlaps with a question that I was somewhat expecting, where someone would ask, like, hey, I have a bunch of custom detection rules. I'm interested in moving to using a Terraform-based detection as code solution. What's a good way for me to move that direction? I'll break that down into kind of two answers. Today, if you're utilizing your own Terraform template, and for example, you could grab the one that I provided on GitHub if it's a good place to get started. It's a bit of a copy and paste game to turn your existing custom rules into a Terraform managed resource that you can use going forward. That said, I have been working with various Datadog project managers, and one of the solutions they are actually working on today, and they're working on rolling out across the Datadog landscape of resources, is the ability to export in a TF or Terraform file format for your existing rules. A request that I would have is, if this is something that anyone else here has interest in being able to quickly export your existing rules to use with Terraform, go ahead and make a feature request. I know that this is something they're aware of, and they've started rolling out functionality in some areas, but it's not on their immediate roadmap to add for detection rules specifically. So if there's a increase of essentially feature requests, that'll show that Datadog needs to put priority on adding that feature so more users and customers can move to Terraform managed rules.
All right, thank you.
Absolutely. Any other questions?
One quick question. When you are getting some alerts into Datadog, you can create some suppression rules from the UI, right? Which is pretty handy. How would you recommend to migrate these UI-based suppression rules back to Terraform in terms of workflow and more like process?
So as far as the suppression rules, I've actually been also talking a little bit with one of the product managers of suppression rules, because I'd really like to see tags added to it. If you recall and think back to, I don't have the slide up right now, unfortunately, but the monitor that I'm using to look at the audit logs, there's a OR logic in there that looks at both the audit log events for detection rules as well as for suppression rules, but I don't have currently the ability to use the support of tags in suppression rules. So one thing that I'm doing is I'm essentially alerting and monitoring on any suppression rule that's created, no matter who is creating or for what purpose, because I don't have a good way to focus them specifically on ones that are being managed and deployed by Terraform with the Terraform tag. So that's one feature I do hope that we see to come soon to suppression rules, is the ability to use a tagging to improve the ability to uniquely monitor those specific resources. And I hope to see that soon, and I know they're looking into some improvements around that.
Thank you. Do we have any other questions from the room? Okay, great. So thanks again, Kelly.
Thank you.